Welcome back. Today we're diving into a really fascinating and dense document.
The Tesseract alphabet canon.
Exactly. And our whole mission here is to unpack this idea of, what's it called? Deterministic non-lying utterance generation.
Which is a mouthful.
It sounds almost impossible, a language where you can't lie.
That's the entire premise. The source lays out this complete closed system where geometry and language are just fused.
Diffused how?
So tightly that the spoken word becomes a verifiable state of the physical world. And it all comes down to the sequence of 3 machine tokens, always 3.
Okay, what are they?
GEO, HEX, and VRB.
All right, so let's break those down. The first one, the VRB token, seems like the simplest part.
It is, yeah. It's just 5 tokens, Va through View.
That's your action token, derived from a simple index, 1 to 5.
Yeah.
Pretty straightforward.
Then you get the HEX syllable alphabet.
Which we can call the index token.
Exactly. There are 16 of them, like ma, me, mama, and so on.
And they map directly from the hex digits, right? 0 through F.
A perfect one-to-one mapping. Very structured. 4 consonant families, but they all share those same 4 vowels. It's the indexing mechanism.
Okay, so action index, and then the last piece is the GEO token, the position token. This is where the physical world really comes in.
Absolutely. This is the key. Those 8 tokens, go, and the H variants, they aren't chosen.
They're derived.
They are derived from the physical state of this object you're holding. Your actual position literally determines the consonant and the vowel you speak.
Wow.
And it's that rigid template, that fixed order GEO, HEX, V or B, that ensures everything follows the geometric logic. The structure is the guarantee.
So we have the ingredients, but the rules for using them are tied to a physical artifact.
Right. The source describes it in a lot of detail. You have to imagine some kind of, I don't know, a complex hilt or a puzzle box.
With all these colorful named surfaces like top yellow 1 or front right red 2.
Yes. And there's this core rule, the Agasile stack law. It basically defines up. One part has to align with another, creating a constant physical reference.
And how you move this thing is also incredibly constrained.
Extremely. The source calls it the legal edge traversal law.
No.
It's almost, well, ritualistic. You only get 2 types of single steps.
Just 2. What are they?
One is a ring step. That's a simple rotation, like turning a dial 90 degrees.
Okay.
The other is an axial step, where you move vertically along the handle from one section to another.
You're keeping the angle exactly the same.
Crucially, yes, the angle cannot change.
It's like every single syllable requires this precise ceremonial move.
Yeah.
The constraints are the proof you're not cheating.
And that leads to the calculation.
This is where it gets really wild. The geometry literally dictates the speech. The physical state of the object gives you these binary inputs.
The mode bit, TM, the rotation class, RK, and one other bit.
Right. And those bits mathematically construct the exact index for that central HEX syllable. The object itself tells you the word you must speak.
And that's the whole process. The source calls it no-lie fielding.
No-lie fielding.
You have to stabilize the physical state, freeze your grip, the angle, the jewel you're on. That determines your GEO and your HEX tokens. Then and only then do you choose your VRB.
And you speak the result.
You speak the derived utterance. Speech becomes, an indexed output of a stable physical truth.
So when you really think about it, what does this all mean for you? The Tesseract canon. And it isn't just defining an alphabet. It's defining a mandatory physical protocol.
It's turning speech into indexable spatial data.
A physical odometer for truth. Which leaves us with the final question to think about. What kind of interaction what kind of trust could only be guaranteed through this rigorous 3-token coupling of geometry and sound? So I was absolutely fascinated reading these sources. We're diving into a deep cut today, the Tesseract alphabet canon. This defines what they call tick speech, and the core of the system is just. It's the most rigorous idea of communication I think I've ever encountered.
Yeah.
This is a language where lying is mathematically impossible.
Right.
Because the words themselves are an immediate, measurable report of reality.
That's exactly it. So for our deep dive, our mission is to unpack the blueprint for this system and figure out how they built that lock. It's all about achieving, and this is their term, deterministic non-lying utterance generation.
Okay.
And the source material is the entire operating manual. It flat out says no token, mapping, or traversal exists outside declared domains.
So it's a completely finite, closed world of speech.
A closed world. Okay, let's unpack how that speech is actually structured.
Right, the output. If you look at it, the language is defined by these extreme constraints. Every single statement, every utterance, follows the same ridiculously strict three-token template. You can think of it as always saying position, then state, then action.
Yeah.
The canon labels them GEOT, HEXT, and Vædrint.
And that constraint is a security measure. It's designed to just eliminate ambiguity. So let's look at that middle one, the HEXT, the state token. It pulls from something called the 16-pound HEX syllable alphabet. 16 syllables, and they're tied to the HEX digits, 0 through F.
And the vowel law here is critical.
Right, it is. The vowels A, E, I, O map directly to the indexes 0, 1, 2, and 3. And that's regardless of the consonant family, whether it's M, T, K, or S.
So, for example, ma is always the digit 0 and ma is always 3.
Always. That rigidity is what guarantees the purity.
Okay, so then you have the GEO tokens, the position.
Yeah.
8 of them split into the G family, so got to go, and the H family, ha to ho. And they report on the object's geometric class. That's determined by a mode bit and a rotation class.
And the last piece is almost an afterthought, the VERB.
The 5 ultra-simple verb tokens, va through vu, is just a hyper-minimal vocabulary.
Well, and if we connect this to the bigger picture, the only way a language can be this constrained but still functional is if it's entirely dependent on a physical system. You have to imagine the language as being read off some complex, multi-sided geometric die that can only be held in specific legal ways.
And that's where the physical input comes in. The object itself is constrained by what they call the axial stack law.
Right, which establishes the persistent up reference.
It's so specific. The pommel's top yellow 1 jewel has to lock into the hilt's bottom purple 4 jewel. If the physical artifact isn't in a stable, defined state, the language literally has nothing to say. No input to draw from.
And movement is just as restricted. You only have 2 legal edge traversal laws defining how the geometry can change.
K1 and K2.
Exactly. K1, the ring step, is a rotation, a plus or minus 90-degree twist within the jewel you're on. But K2, the axial step, is a traverse. You move between the pommel and the hilt, but your angle must stay the same.
Wait, so if I try to move the object in any other way, say a 45-degree rotational twist,
Invalid.
the whole state would become invalid.
Precisely. Any state that can't be reached by a series of legal K1 or K2 steps is just irrelevant to the canon. It doesn't exist.
Wow.
And this brings us to what they call practice truth compression, or no-lie fielding.
Okay, so this raises the big question. How does this immutable physical state become the immutable utterance?
That's the key.
The required steps are startlingly clear. To generate a true utterance, you first have to freeze the object in a stable physical state. The specific grip, the angle, the jewel that's in focus. That geometry provides the precise variables, the mode bit, the rotation class, the ID for the formulas.
And those variables map directly, mathematically, to the 3 syllables that are spoken.
So the spoken output, that GOHE, XE, HE, beat, is an immutable readout of the geometry.
It's a direct, non-negotiable report on the state of the artifact you are holding. You cannot utter a lie because the language is the state of that small piece of the universe.
What really stands out to me is that this is a language where every single word carries the undeniable weight of physical proof. Its meaning is literally determined by which way you're holding the object.
It's a closed-loop system. It guarantees objective truth by eliminating all subjective interpretation.
An architecture of certainty.
Exactly.
Our deep dive into the Tesseract alphabet canon is complete. So here's a final thought to mull over. If this language requires a stable physical state to generate a true utterance, what fundamental truth does this deterministic canon suggest about the instability, or maybe the necessary subjectivity, of our own language? A language that relies solely on sound and shared, often shifting, agreement. Welcome to the deep dive. Today we are jumping into something pretty fascinating. It's called the Tesseract alphabet canon.
And specifically, we're looking at tick speech, which is a communication system from the canon with a very, very particular goal.
Right. It's designed to be fundamentally incapable of lying.
Exactly. That's the whole promise here. They call it deterministic, non-lying utterance generation.
Which sounds a bit academic.
It does, but what it really means is that every single word is a direct, traceable readout of a fixed physical state. I mean, if the system works like that, lying about the state it's structurally impossible.
Okay, so let's unpack that. The entire language, as I understand it, boils down to just 3 components.
Just 3. They call it the tick utterance template.
Geometry, syllable, and verb. So if you're speaking tick speech, you're always saying this exact 3-token sequence.
And it's derived directly from what's physically happening.
Yeah.
So let's start with that first token, GEO, the geometry token.
This gives you one of 8 sounds, right? The G or H families.
Yep. And those sounds are determined by two absolute physical readings. You have what's called the mode bit, or TM.
Which is sort of like an on-off switch.
You can think of it that way, yeah. It picks the consonant family. And then you have the rotation class index, RK, which is a direct physical readout. It locks your utterance into one of 8 choices.
Okay, so GEO gives us our general location.
Yeah.
And the second token, HEX, the hex syllable, it refines that.
It takes those exact same inputs, the TM and the RK, and it gets more specific. It locks you into one of 16 possibilities, like the M or S families.
And this is all based on something called the Nibble construction law.
Precisely. It's just a calculation. That physical input data forces the system to output one of exactly 16 syllables. It's a completely closed system.
Then we have the third token, VERB. And this is a really short list, just 5 vowels.
Va, ve, va, bo.
But wait a minute. If the whole system can't lie because it's derived from a physical state, how can any part of it be willed or chosen? Doesn't that reintroduce ambiguity? The ability to lie?
That is the perfect question. And that's where the process comes in. The canon calls it the practice truth compression rule.
Or no-lie fielding?
Right. And it's a required 4-step process. First, the speaker has to freeze until their physical state is totally stable, no movement.
Okay.
Then, they determine the inputs for GEO and HEX from that stable state. Now, they can choose a VERB ID.
Ah, so there is a choice.
There is, but, and this is the key, the rule requires them to speak the exact 3 tokens in order: GEO, HEX, VRB. So the language doesn't lie about the state. The verb only changes the context or the intent relative to that undeniable state.
To really get how this language can't lie, we have to look at the geometry that anchors everything.
Absolutely. The source material defines an axial stack law. Just imagine 2 rings, a pommel, and a hilt.
Like on a sword.
Sort of, yeah. And they create this persistent defined reference for up and down. For this language, they are the North Star.
And they named every single orientation point. The level of detail is just.
Yeah.
It's intense. For instance, the 0-degree point on the pommel is the Alujrëx.
And on the hilt, it's Slarñok. You don't need to memorize the map, but you need to appreciate that level of rigor.
And the system only recognizes 2 legal ways to move between these points.
2 valid state changes, yeah. The first is a ring and step. That's just a 90-degree rotation on the same ring.
Okay.
And the second is an axial step. That's where you move along the handle, say from the pommel to the hilt, at the same angle.
And even that specific move has a name. The sources say moving from Ñawlix to Slarñok is called degen.
So if you put it all together, the canonical summary basically says every single utterance is the direct, explicit output of a defined geometric state.
You can trace every sound back to a physical, verifiable location and movement. It just completely strips out ambiguity.
So we've explored a language where all the inputs are, physically verifiable, they're finite, they're closed.
And if your statement is just the required readout of a stable physical state, then it's logically impossible for that statement to be a lie about that state.
Which leaves you with a really important question to think about.
Yeah.
What would the world actually look like if all human language had to be derived from a closed, finite, and physically verifiable set of inputs? If making lying structurally impossible was a feature, not a bug?
Something to consider the next time you choose your words.
Okay, let's dive in. We are unpacking the Tesseract Rhombic 3D GR Joule plus Song Bus V9.1. It's a really dense specification, and our mission here is to figure out what this holistic rhetorical architecture is actually doing.
And what's so fascinating, I think, is the core premise. It flips the usual script. It's not software first. This whole thing is designed to take a specific, committed physical state.
Like how you're literally holding an object.
Exactly. How you hold this geometric jewel, and it translates that physical truth into a single constrained verbal utterance. The prime directive here is that physical truth comes first. Speech just audits it.
And that physical core is the 3D GR Joule. It's got 2 parts, right? The pommel ring.
Because slots 5 through 8, yep.
And the hilt ring slots 1 through 4. And the documentation is very specific about the grip. It's not a gentle placement. It says one part impales the other.
It does. The pommel's top yellow phase commits to the hilt's bottom purple. The physical setup is totally absolute. And that immediately triggers the logic.
Through color, which is the 3-bit triad decoder.
Precisely. That's the bridge. You have 6 phase colors, and they're mapped to 3 binary literals, A, B, and C, and their negations. So if A is purple,
then yellow is just not A.
Exactly.
Okay, so that brings up the deities. Is a deity just a fancy name for the geometric state, or is it doing more? The source says the intersection of, say, yellow, red, and blue, the 1,000-state maps to the deity Alujrëx.
It's both. It's a label, for sure, but it's also a logic gate. Every 3-bit color combo gives you one of 8 deities. But here's the crucial part. Those deities are organized into 4 axis regimes.
The KR, DL, VN, and ST.
Right, and you can just think of those as the system's 4 basic operating modes. They function as core machine state variables, 0, 0, 0, 0, 0, 1, 10, and 11.
So we've gone from physical grip to color to logic. Now, how does the system actually speak? This brings us to the execution protocol.
It all comes down to slot 1. The I-degree thumb knuckle. Whichever deity lands there drives the whole process.
The PLCD to derive to speak pathway.
Yep, that one deity on slot 1 gives you the timing marker, or TM. And so 1 if the ring is Løklaz, 0 if it's pommel. And then the deity binding table gives you the RK, that's the axis regime, and the V bit. So for Alujrëx, the state would be 0, 0, 0.
So now we have the full machine state, TM, RK, and V bit. And that gets calculated into what, the nibble index, the NIB.
That's it. It's an index number from 0 to 15. The NIB selects a specific HEX syllable from the alphabet, ma, mi, or ka. At the same time, the TM and RK pick a GEO token, like ga or hi.
And the final utterance has to be exactly GEO, HEX, VRB. Nothing more, nothing less.
A rigidly constrained vocabulary.
But this is where it gets really counterintuitive. The V9.1 overlay, it's not enough for the physical grip to be correct. Now there's this FAB24 constraint.
With the Fibonacci constraint, this is wild. For 24 ticks, the overlay demands that the NIB follows the Fibonacci sequence, mod 16. So 1, 1, 2, 3, 5, 8.
Okay, wait. Let's walk through that. What if my physical grip is locked in and it's generating an NIB of, say, 10, but we're on tick 5 and the Fibonacci rule demands an NIB of 5? The physical truth and the math are fighting. What happens?
And that is the absolute core rule of the system. If the physical state cannot realize the required Fibonacci NIB, the system executes no tick.
Silence.
Silence. The system chooses to say nothing rather than say something that violates the mathematical pattern.
So think about what this means for you, the learner. We have this perfect closed-loop system. Physical placement becomes logic, but that logic has to sync up with an external mathematical pattern just to produce sound.
This is an architecture that prioritizes adherence to a pattern over expressing an immediate physical truth.
It really is. The system would rather be silent and correct according to the pattern than be vocal and wrong.
Which leaves us with a really provocative final thought. What are the implications of a rhetorical architecture where, if you cannot realize a required state, your only acceptable output is silence?
All right, so today we're diving into a really dense document. It's called SLAB V10 10.03 3DGR Joule plus state surface.
And it's not a typical software spec. It's more like a blueprint for a system that tries to lock physical reality directly into language.
Exactly. Our whole mission here is to sort of unpack how it works. How do they merge geometry, binary code, and actual phonetic sound into one auditable state? And, get rid of all ambiguity.
Well, the whole architecture is built on a single core rule. They call it the prime directive.
The prime directive.
Right. And the idea is that knowledge gets built up in layers. You start with geometry, then binary, then language, but nothing can be lost along the way. The key phrase they use is, geometry remains visible even when language is spoken.
Okay, so how do they even guarantee that?
It comes down to one constraint, a really strict one. No field is permitted to carry 2 meanings. If you need a new meaning, you need a totally new, distinct name. That's it. That one rule makes the whole thing auditable.
Okay, let's unpack that. Where does it start? The physical foundation is this thing called the 3DGR Joule. What even is that? Is it like an actual object?
It is. It's the reference frame. Think of it as a physical artifact that provides the initial context. And the docs are very specific. They say the pommel, which is top yellow 1, has to impale the hilt, bottom purple 4.
Impale, so it's a physical intersection. That's the input.
Exactly. That geometric event is the state input. It's not a metaphor.
And that physical act gets translated directly into, what, a 4-bit binary code, the I belly.
Right. And those 4 bits, B3 down to B0, they're not arbitrary. They capture 3 very specific measurable properties of that geometric intersection.
Like what?
So B3 tells you the component class, B2 and B1 define the axis regime it belongs to, and B0 just flags the specific endpoint being observed. It's a direct structural mapping.
This is where it gets a little strange for me. The documents talk about a triad decoder that links 3 of those bits to 8 deity names. Why bring deities into a technical system?
I think it's just about having fixed, unambiguous labels. They're not religious figures. They're just names for categories.
So, like placeholders?
Sort of.
Okay.
They function as non-ambiguous names for the 4 possible axis regimes. So instead of just having a binary string like 0, 0, you have a recognized category with a name. It's the bridge from the raw geometry to a computational category.
Okay, I see. So the geometry forces the binary, and the binary gets a fixed name. Now, how do you make that audible? How do you get to the sound without introducing ambiguity? This is the song BS naming law, right?
Yes, and this is maybe the most novel part of the whole system. It's a completely deterministic phonetic rule set. The 4-bit NABAE maps perfectly to one syllable.
How does that work?
It's a simple grid. The first 2 bits, B3 and B2, they give you the consonant family. They call it the row law. So 0, 0 is M, 0, 1 is T, and so on.
And the other 2 bits?
The last 2, B1 and B0, define the index vowel, the column law. 0, 0 is A, 0, 1 is E. You get the idea.
So if you hear the sound, you instantly know the binary. Okay, let's take their example. A nibble of 11, 10. The first pair, 11, gives you Rs.
Right.
And the second pair, 10, gives you R.
Put them together.
Psi. The sound is the data.
Exactly. And when a state is fully confirmed, what they call a tick, the system gives you a complete utterance. It's a 3-part sound string. You get the syllable for the geometry, the one for the binary state, and another for the action. The full example they give is ho si va.
So what we're looking at is a system engineered from the ground up to just eliminate ambiguity. The physical truth is designed to be instantly spoken and computationally clear.
It is. Total deterministic transparency is the goal. But that raises a really important question, one for you to think about. In a system like this, which demands perfect truth, what's the trade-off?
What do you mean?
The rules state that if a required physical value can't be made true, the system commits NOTICK. It just results in silence. If truth can't be realized, the system literally says nothing at all. So what new kind of uncertainty do you create when the price of avoiding ambiguity is complete silence? Welcome to the deep dive. Today we're jumping into something that is, let's just say it's dense. The SLab V10.03 specification.
It's a fascinating document, though, really rigorous.
It is. And our mission, really, is to unpack how this system takes a fundamental physical truth and translates that, well, directly into an auditable sound.
And the complexity all grows from something so simple at its core. It starts with this one geometric object, the 3D-GR jewel.
That's the one with the 6 indexed colored faces. Top yellow 1, bottom purple 4, and so on.
Exactly those. And the entire state of the system, I mean, the whole thing, kicks off from one single event. It calls it the construction assertion.
Right. Pommel top yellow 1 emerges and impales hilt bottom purple 4.
That specific physical act, that relationship is the source of all the data that follows.
So if that's the physical commitment, how does it get into the digital world?
It's an immediate, strict mapping.
To the 8 deities, right?
Yeah.
Names like Alujrëx and Slarñok.
Yes, and their status is assigned using what the spec calls a triad decoder. It's based on 3 positional bits, A, B, and C.
And this isn't a metaphor. The geometry is the input for those bits.
Precisely. And those A, B, and C bits, in turn, directly define the most critical unit in the whole system, the 4-bit NEBLE.
Okay, B3, B2, B1, B0. So what is that nibble actually snapshotting?
Well, each bit has a job. The B3 bit, that's the ring class. It just tells us if we're looking at the pommel or the hilt.
Simple enough. And the 2 in the middle, B2 and B1.
That's the pair class. It's the context, derived from which deities are involved. You know, the KRDL VN pairs.
Got it. And the last bit, B0, just pins down the specific endpoint in that pair.
You've got it.
But wait a second. A standard 4-bit system that should give us 16 possible states from 0 to 15.
It should, mathematically. But this is where the physics of the jewel just slams the door on pure math.
Ah, this is the physical constraint, the reachable set.
Exactly. It dictates that only 8 of those 16 nibbles are physically realizable.
So which ones are they?
The set is 0, 2, 3, 5, 9, 12, 14, and 15. Only those 8.
And if the geometry results in a target outside that set,
nothing happens. No to key. It's deterministic silence. A failure to commit is literally built into the physics.
wow, so only half the binary space is even usable. And if a tick does happen, it has to be audited.
Okay.
Which brings us to the songbus naming law.
This is the genius layer, I think. It's how the 4-bit state gets embedded directly into a spoken syllable, the HEXSYL.
So how does that work? How do you turn 4 bits into a sound?
You split them. The first 2 bits, B3 and B2, they're the row bits. They pick the consonant family, so M, T, K, or S.
Okay.
Then the last two bits, B1 and B0, are the column bits. They select the vowel index, A, E, I, or O.
So let's take an example, MBBLE 14.
Okay, 14. In binary, that's 11, 10. So the row bits are 11.
Which maps to the S consonant family.
And the column bits are 10, which maps to the I vowel.
Put them together.
See?
Exactly. The sound you speak is the binary 1110.
That is wild. But the final utterance isn't just that one syllable, is it?
No, that's just one piece. The full oddest string, U-Torter, is 3 parts. You get the GOCL, which represents the geometry, then the HEXLL we just talked about.
And finally, the V or BSYL for the actual action. That complete linguistic sequence is the proof of the physical state. You can't substitute it.
So, connecting all the dots here, SLAB V10.03 is this incredibly rigorous machine where geometry and binary aren't just represented.
They're audited, committed, through a deterministic language.
Which brings us to our final thought. The prime directive in the spec is very clear. It says the binary remains visibly encoded even when the syllable is spoken.
Right, the phonetic law is just an auditable encoding, not a replacement for the data.
So here's something to think about. What does it imply about the nature of truth, or even complexity, when a single spoken sound is fundamentally required to carry a hidden, non-erased 4-bit numerical state? It means speech itself becomes a piece of unalterable, committed data.
All right, welcome back. We are diving straight into the architectural blueprint of SLAB V10.02.
And it is quite a blueprint.
It really is. It describes itself as a closed and deterministic system, which is a massive claim. The whole mission here is to unpack its prime directive.
Which sounds very sci-fi, but it's a core technical assertion.
Exactly. The idea that nothing disappears when another layer speaks. It demands that the geometry, the binary, and the language are all visible at the same time.
All fully auditable. And that's because of their foundational rule.
Mm-hmm.
Physical truth is committed first.
What does that actually mean, committed first?
It means speech isn't an act of creation in this system. It's just an audit. It's a reading of a physical state that already exists. That way the geometry and the data always stay printed, so to speak.
Okay, so if the whole truth depends on a physical thing, we have to start there with the anchor.
The 3D-GR jewel.
Right. This object defined by 6 distinct colored faces, like OSA top yellow 1, and OS bottom purple 4.
And the core interaction is what they call the construction assertion.
Where the pommel, saw top yellow 1, emerges and impales the hilt, sum bottom purple 4.
That physical commitment is what locks everything else in. The jewel has 8 specific rotational spots, R0 through R7, and they're anchored to these 2 compass rings.
The pommel and the hilt.
Right, which are themselves anchored to angles and even named after deities. It's all about making sure every single physical position, or GRP, is completely unambiguous.
Okay, so we have the physical geometry rock solid. How do you get that into, ones and zeros? How do they digitize that state?
They do it with a 4-bit NBLE.
A nibble?
It's essentially an instantaneous digital fingerprint of the jewel's physical position, and the mapping is 1-to-1. Totally direct.
How direct are we talking?
I mean, the highest bit, B3, just tells you if you're holding the pommel or the hilt. The next 2 bits, B2 and B1, define which axis you're on. So if you know the GRP 1 of 8 positions, you know the exact 4-bit binary state, period.
And I saw that the colors on the faces also power something called a triad decoder?
Yeah, that's another cross-reference. It links 3 binary bits directly back to those 8 deities. It seems like every piece of data has multiple physical backups. It's all about auditability.
Which brings us to the language. This is where it gets, I think, really wild.
The auditable language, yeah.
All
This
right.
is the final test of their system.
Where that 4-bit binary state gets encoded directly into a single spoken syllable.
It's like a vocal QR code. They call it compositional binary in phonetics.
Okay, let's break down that rule. It's surprisingly simple.
It is. Consonants M, T, K, S. They just map to the first 2 bits, the row bit.
B3 and B2, and the vowels A, E, I, O map to the column bits B1 and B0.
That's it. So the nibble 0000 becomes the sound.
Ma.
And the nibble bias 11 becomes so. But the key is that the sound, the ATXSYL, is an auditable encoding.
Right. It doesn't replace the binary. It is the binary, just in spoken form.
Exactly. It fulfills the prime directive. The binary is still there, and so is the geometry through other spoken parts like geometry tokens. The whole utterance is just a chain of causality.
So let's pull this together for you. We've just walked through a system where the physical location of an object determines a binary code.
Which in turn determines the very sound of the language used to describe it.
It really feels like the ultimate closed reality, but then there's a catch.
A big one, the overlay rules.
Yeah. So what do these do?
Well, they constrain the nebulae. The state of the jewel is forced to match a target that's derived from an external mathematical pattern,
Not just any pattern, right? The Fibonacci sequence.
specifically the FEB24 targets. And that raises a huge question. In a system that is so dedicated to being deterministic, why do you need an external, purely mathematical rule to dictate the desired state?
So that's the final thought for you to mull over. This Fib24 targets overlay rule, this abstract sequence of 1, 1, 2, 3, 5, 8, it isn't generated by the jewel. It's an outside input. Could that be the one and only driver needed to steer an otherwise perfectly rigid, self-contained reality? Something to explore.
Welcome back to the deep dive. Today we're jumping right into an architecture of absolute constraint. The system is called SLV 10.02, and our mission is to unpack how it forces this total merger between physical geometry and, well, language itself.
Yeah, the key thing to grasp right away is this prime directive. It's simple. Physical truth is committed first. Speech audits what was committed.
So is radical transparency.
It has to be. Geometry, bits, syllables, every single element has to stay visible. There are absolutely no implied layers.
Okay, let's unpack this then. If we're dealing with absolute physical truth, we have to start with the object that defines it, the 3D-GR jewel. This is the foundation, right?
It is the canon. It's a geometry with 6 named faces, like Acetop Yellow 1 and Sama Purple 4. But what really defines the whole system is this incredibly vivid construction assertion.
I love the phrasing on this.
It's great, isn't it? The pommel face emerges and impales the hilt face. That specific physical act, the construction, that is the truth.
Yeah.
Everything else just follows from that.
That's such a dramatic way to describe geometry. And it's all anchored by these named compass rings on the pommel and the hilt. Each point is tied to a deity name, like Ñawlix or Thadlērio. The mapping seems brutally efficient. So how does that physical rigidity immediately become information?
Well, it becomes binary data instantly. Yeah. The physical GRAP location, your point of interaction, it defines the system's primary output. A 4-bit nibble.
Okay,
and that nibble is the raw data. It's derived one-to-one from the geometric state. We can even break the 4 bits down. B3, the first bit, tells you the authority. Are you gripping the hilt or the pommel? 1 or 0.
Simple enough.
And the other 3 bits define the precise axis regimes, the pair class, and finally, which endpoint in that pair you chose. The whole physical position is now basically an ID tag.
Wow. So the location of the GRIP is the raw binary data. There's no semantic drift possible because the binary is just, it's engineered into the construction itself. Okay, so if the grip is the data, then how does this translate into audible language?
That's where the song-based naming law comes in. Version 8.1c specifically. It maps that exact 4-bit nibble directly into an audible syllable.
A mechanism you call phonetic binary encoding.
Exactly. The structure is fixed, it's auditable. The first 2 bits always map to one of 4 consonant families, M, T, K, or S. The last 2 bits map to the index vowels, A, E, I, O.
I see where this is going.
So to use the classic example, if your drip gives you the nibble 1111, that immediately translates to the syllable so. You can't speak so unless the physical state 1111 is actually true.
The sonic output is just the visible printout of the underlying geometry. That enforces absolute accountability.
Precisely. The final utterance, which is this audit string of different syllable types, it can't hide anything. The system is closed, it's deterministic, and it ruthlessly enforces that no implied layers rule.
Which leads us to that final really powerful rule. If a required physical value just can't be made true,
you get no tick. Absolute silence. The system will not allow a lie. Not even by omission. And if we connect this to the bigger picture, this system demands an absolute commitment to the physical state as the primary truth.
Right.
So that raises a pretty important question. When language is reduced to only auditing something that has already physically happened, how does that change the nature of command or trust?
Think about that. The SLAB system defines a rule where truth is geometric, and language is merely the visible printout of that truth. If you built a company or a government on this, no one could speak unless the physical verified state was perfect. Is silence the price of absolute truth? Or does eliminating ambiguity just shift all the complexity, all the risk, to that first act of physical construction? Something for you to chew on until next time. Welcome to the deep dive. Today we're really trying to get our heads around SLAB v10.02. And I think to start, you really have to forget everything you assume about language or, even programming.
Exactly. This is a system where geometry, binary, and sound are just, well, fused together.
So what's our mission here? What are we trying to understand?
It all comes down to the prime directive. The source material is very clear on this. All layers, the geometry, the bits, the syllables, they all have to be visible and committed at the exact same time.
So nothing disappears.
Nothing disappears when another layer speaks. That's the key.
Which feels like a huge reversal of cause and effect. Language isn't just describing reality, it's the sound of reality being true in that one instant.
Right. And the thing that locks it all down, the highest law, is that the system is closed, deterministic, and has absolutely no remaps.
Okay, what does that mean, no remaps?
It means physical truth is absolute. It comes first. The speech, the sound that comes out, is only an audit. It just confirms what was already physically committed.
Okay, so let's break down that physical commitment. The 3DGR jewel, it's built on these distinct faces, right? The top yellow, the bottom purple.
Yes, and it guarantees its own starting state with something the texts call a construction assertion.
A construction assertion.
Yeah, it's a physical rule. The top piece, the pommel, must emerge and impale the bottom piece, the hilt. That alignment is fixed. It's not negotiable.
And that's where the deities come in. I mean, figures like Ñawlix and Thadlērio. It seems strange to bring them into a mechanical system.
It does, but it just shows how serious the physical commitment is. The deities are associated with the compass rings on the pommel and hilt. It, literally grounds the divine in the geometry.
So the physical alignment is locked.
Yeah.
How does that six-sided reality get translated into numbers, into the bit plane?
Deterministically, always. The physical state is forced to map onto a 4-bit code. We call it the nibble. You can't argue with it.
And the bits themselves have specific jobs, I assume?
They do. The highest bit, B3, that just defines the ring class. So TM equals 0 means you're talking about the pommel. TM equals 1, you're on the hilt.
Simple switch.
A simple switch. Then the next 2 bits, B2 and B1, they define the axis regimes. So whether you're in the KR or the DL regime, which, again, are linked to deity pairs like Omvartïs and Alujrëx, is decided purely by the geometry.
So now we have a physical state and a number that proves it, but we need to make audible, right, to make that binary visible.
And that's the song bus naming law. We're using sound to prove the number, which in turn proves the geometry. It's the auditable encoding.
How does that work?
It's a surprisingly simple consonant and vowel matrix. The HEX syllable, the row bits B3 and B2 map to one of 4 consonants M, T, K, or S.
Yeah.
And the column bits B1 and B0 map to one of 4 vowels A, E, I, or O.
So if the nibble is, say, all zeros, 1000, that would be mam.
Right, mam. And if the system is at its absolute maximum 1111, you get so.
And there's a second syllable too, the GEOSYL, just to double check everything.
Right, using G or H consonants. It's all about that double check. Which brings us to the tick surface.
The tick surface.
Think of it as one single, indivisible snapshot in time. In that one instant, everything has to be present. The alignment, all the bits, both syllables. The final utterance is just a simple audit string of that state. Geosyl, hexalyl, verbsyl.
And this brings us back to what I think is the iron rule of this entire system. What happens if that physical state can't be achieved? If the parts don't align perfectly?
And you get a no tick.
Silence.
Absolute silence. The system can only speak if the physical commitment is 100% true. The physical state dictates the word.
Or its absence dictates the silence.
Exactly.
So what does this all mean for you listening to this? When a system like SLab insists that language is only an auditable encoding of an already committed physical state, what happens to our concept of meaning? If a word is purely descriptive and never generative, does it lose its power to influence or even to imagine? Something to think about. All right, welcome to the deep dive. Today we're tackling a document, a really dense one, the holistic rhetorical architecture for the tesseract rhombic system, V9.1.
It sounds intimidating.
It does, but our mission here is actually pretty straightforward. We want to understand how a physical object's position, its orientation, leads directly and deterministically to a specific linguistic output.
And you have to start with the prime directive, the canon lock. It really reframes everything for you.
What's that?
It's simple. The physical state of the system is the absolute truth. The document even says speech audits what was committed.
Speech audits what was committed. Right. So language is just the proof of a physical act.
Exactly. And if the machine can't physically achieve the required state to say a word, It says nothing. It issues a no-cut, just silence.
Okay, so let's walk through that physical commitment.
Yeah.
Where does the input actually, begin?
It starts at the operator's hands with the 3D GR jewel. Think of it as having two rings. You've got the pommel with deities like Ñawlix and Alujrëx.
And the other ring.
That's the hilt. It holds Slarñok, Omvartïs, and the others.
Okay, wait. If the physical position is the absolute truth, why bring deities into it at all? Isn't that just an extra layer of abstraction?
That's the fascinating part. The deities are the logic labels. They aren't just names. The system uses what it calls a color as literal binding. Meaning, for instance, yellow might literally be not A, while purple is A, red is not B, green is B, and so on for 3 bits.
So when 3 colors physically intersect on the jewel,
you get one of 8 unique 3-bit states. A physical intersection of, say, yellow, red, and blue gives you the binary state, 1000, and that state 1000 is the deity Alujrëx.
And the machine reads this from one specific spot.
One tiny sensor point, the I-degree thumb knuckle on the grip. That reading, the vertex deity, is the absolute source for all computation that follows in that tick.
So Alujrëx is red. Now what?
That immediately dictates the output parameters, the regime, or RK, and the V-bit. For Alujrëx, the base state is set to 000, no ambiguity.
And then there's the other physical input, the grip ring.
Right. Which ring is active? The hilt sets the TM bit to 1, the pommel sets it to 0.
And this combination of TM, RK, and V-bit, this is where the system's flexibility just ends, because it all gets fed into the 4-bit emboli index.
The formula is completely deterministic.
NIB equals TM times 8 plus RK times 2 plus V-bit. So the grip input, the TM bit, is weighted most heavily.
It is. And that calculation gives you a number, an index from 0 to 15. That index then just points to a syllable in the HEX alphabet.
16 pounds. So index 0 could be ma, index 1 me, and so on.
Yes, but here's the critical constraint, the V9.1 overlay. It's called Phi B24.
And this is the real authority, isn't it? The operator can't just align to any physical state.
No, not at all. They have to align to a state that produces an emboli index that matches a predetermined mathematical cycle.
The Fibonacci sequence.
The Fibonacci sequence modulo 16, to be precise. It's a pattern that repeats every 24 ticks. 1, 1, 2, 3, 5, 8.
So if the machine is on, say, tick 6 of its cycle, the target number is 8. The physical state must generate an emboli index of 8.
Or the system falls silent. Oh no, TCK.
But if it does align, if the physical orientation perfectly matches the mathematical target,
then, and only then, does the machine speak. It utters the required template, GEO, HEX, VRB, usually with a default VRB, so you get a sound like VA.
So we've gone from the color and grip of a physical jewel through a deity mapping into a number that has to align with an ancient mathematical pattern just to produce a single syllable.
That's the whole chain. The only way the system can sing is through total physical conformity to this external abstract pattern. The language is just the receipt. It's the proof that the operator did it right.
Which leaves a pretty big question for you to think about. What does it actually mean when a purely abstract mathematical pattern like this 24-tick Fibonacci cycle is imposed as the sole authority, deciding whether a physical language-generating system is even allowed to speak? Keep digging deeper. Welcome to the Deep Dive. Today we're breaking down the architecture of CESLab v10.03.
Right.
It's this hyperstructured system that, well, it forces physical geometry to dictate everything, digital code, even spoken language. So our mission today is to trace that flow of authority, to see how the system makes sure its physical truth is committed first.
And then how the language part, the Songbus naming law, comes in to basically audit that truth.
Exactly, an audit.
And the sources are really clear on this. The framework is completely uncompromising. It's closed.
And deterministic.
Exactly. And the core rule, the one that governs everything, is that geometry remains visible even when language is spoken.
So everything has to have a physical root.
It has to. Before it can be a word, before it can be a number, it has to exist in the physical world first.
Okay, so let's start there with the physical master, phase 1. The geometry.
The foundation of it all.
Which is the 3D GR jewel, the core object. It's defined by 6 color-coded faces, so you can think of things like, top yellow 1 and bottom purple 4.
And the key interaction, the only one that really matters for the core state, is this very specific mechanical act.
The pommel, top yellow 1, emerging and impaling the hilt, bottom purple 4.
Right, and those 2 locations, pommel and hilt, they anchor the entire digital map.
So the system assigns specific deity names Ñawlix, Thadlērio, and so on,
Slarñok, Omvartис.
as these rigid labels for the 4 cardinal compass points on both rings, 0 degrees, 90, and so on.
And that's how it labels its coordinate system. So that active impaling isn't symbolic.
Right.
It is the literal bit setting for the entire state.
So with that geometry fixed, how does the system force it into its accounting ledger? The 4-bit numbly,
B3, B2, B1, B0 structure.
that code is derived directly from that geometric GAP state using those deity labels we just mentioned.
It's a very, very controlled derivation. So B3, the most significant bit, just tells you the physical location. 0 for pommel, 1 for hilt. Simple.
Okay, so that's located.
Then you get B2 and B1. These are the axis regimes. They identify which specific deity pair is active. We can just call it RK.
Like the Omvartis and Alujrëx pair being RK00.
Exactly. And then finally, B0 just specifies which endpoint of that pair is the one that's active.
And this whole process is driven by that one mandate, right?
No field is permitted to carry 2 meanings. It's incredibly strict. If a concept needs even a tiny bit of nuance.
It has to get a whole new name, a whole new slot.
A whole new slot, that's right.
That sounds incredibly restrictive. I mean, does the source mention the overhead cost of this? It feels like you're building this giant complex auditing system just to prove 1 + 1 = 2.
Well, that's the point, isn't it? It trades conceptual efficiency for infallible auditability.
Okay.
So we fixed the geometry, we've translated it into 4 bits. Now, why the language?
The audit.
The audit. Phase 3 is the song be use naming law, and it's all about making that binary structure audible.
Okay, so let's see this audit in action. The core of it is the ATX syllable.
The 16 pounds, yeah.
And it uses a compositional phonetic binary rule. So think of it like a tiny 4x4 alphabet.
Right. The row bits, B3 and B2, they map to one of 4 consonants, M, T, K, S.
And the column bits, B1 and B0, map to one of 4 vowels, A, E, I, O.
That's it. So if your Naiba D is 1110, that's decimal 14, the row bits 11 give you as.
And the column bits, 10, give you I.
So the resulting syllable is se. That sound literally is the number 14. There's no ambiguity.
And a full successful tick is captured in the complete uterance.
Utter.
It's GOCL plus XAL plus verb CL, and that first part, the geometric token, is generated separately.
Because it's naming the relationship between the active ring and the axis regime.
So if TM1 and RK is 11, that geometric relationship generates the token Ho.
Exactly. So a full successful tick might sound something like Hosiba.
And the hierarchy of authority here is fascinating.
It really is. The language is just, as the source says, an auditable encoding. It doesn't replace the numeric law.
It exposes it.
It exposes it. The physical and numerical reality must happen before the word can be spoken.
But there's a catch, a pretty big one. The system has these rigid physical constraints. The source mentions the FIB24 training sequence. And how, even if the system is fed a target number, say, the joules mechanism can only physically generate a very specific, reachable set of nibbles.
Which is 0, 2, 3, 5, 9, 12, 14, 15.
And you'll notice 1 is not on that list.
Which brings up the ultimate question of authority, right? What happens when the system physically cannot realize a value that's being demanded of it?
The source is blunt about it. There is no tick.
Silence.
Just silence.
Yeah.
The physical inability to commit the truth overrides the numerical target.
So that failure to complete the tick, it only gets noted by a trace-only token, something like ka in the log, but nothing is spoken.
The physical constraint holds absolute veto power over the target number. A pretty powerful example of how, in this system, geometry really does dictate everything.
Okay, let's dive in. We're looking at a piece of architecture today that honestly sounds like something out of a cipher manuscript.
It really does.
It's called the Tesseract Rhombic 3D-GR Joule plus Songbus V9.1.
A real mouthful. But
yeah,
our mission here is pretty clear,
Yeah.
We need to unpack this deterministic system. Its whole purpose is to translate a physical state, how someone is gripping an object, into machine speech.
A tick utterance, they call it. And that physical input is everything.
It is. You have this 3D-GR Joule with 2 sets of rings.
A hilt and the pommel.
Exactly. And 6 face color bindings, like top yellow or bottom purple. And these aren't just, decoration. They're the starting point for all the logic.
And this is where it gets a little esoteric, right? The deity compass.
Right. So you have 8 named deities, Ñawlix, Slarñok, names like that.
Uh-huh.
Each one is just hard-coded to a compass angle on one of the rings.
Yeah.
Think of them less like gods and more like, 8 predefined memory registers.
So how does a physical color like yellow point to one of those registers? That seems like a big leap.
Well, that's the genius of the color logic mapping. It uses a 3-bit triad decoder.
Okay.
The colors themselves function as bit literals. It's surprisingly simple. Think of yellow as not A, while purple is A.
So they're just on-off switches?
Precisely. Red is not B, green is B, and so on. Where 3 of these colors physically intersect, you get a unique 3-bit binary state.
And that state is the deity. The sources give the example of the thousand state, which is not A and D, not B and D, not C, and physically that's the intersection of yellow, red, and blue.
And that combination, that specific grip, is Alujrëx.
Wow.
Correct. So the physical grip fixes this vertex deity, and that's what drives the machine's speech. It all funnels down into one critical number.
The NEBLE index.
Yep, a number from 0 to 15, and it's calculated from 3 inputs, all derived from that same physical grip.
Okay, let's unpack those 3 inputs because this seems to be the foundation of the whole Vædrint.
Right. First up is TM, the ring class.
Simple enough. Is the main grip on the Hilti, which is a 1, or the pommel, which is a 0?
Exactly. Second is RK, the regime. The vertex deity you've selected falls into one of 4 axis regimes, and each regime has a 2-bit code, 0, 0, 0, 1, and so on.
Then the last one.
The V bit. It's just a single bit, a 0 or a 1, that says which of the 2 deities in that RK pair you've chosen. So for the KR pair, Alujrëx is 0, Omvartïs is 1.
So once you have TM, RK, and V bit, what's the final formula to get that all-important MB belief?
The calculation itself is really quite elegant. It's just NIBT equals TM times 8 plus RK times 2 plus the V bit.
And that single number, 0 to 15, that's what selects the speech.
It selects the core of the speech. The tick utterance has this rigid 3-part template, GEO, HEX, and VEER. The Newable picks the HEX syllable from a 16-syllable alphabet.
Now, this is where it gets really interesting for me, the V9.1 overlay.
The EV24 constraint, yes.
The genius here isn't just the complex input mapping, it's the elegant brutality of the constraint on the output.
Precisely. The whole system is designed to hit a specific numerical target. That required n-ability index for any given tick has to follow the Fibonacci sequence.
Modulo 16.
Modulo 16. So it has to go 1, 1, 2, 3, 5, 8, and so on through its 24-tick cycle. It's this purely mathematical rule forced onto a physical action.
Which brings up the most critical question. What happens if the person holding the jewel just can't?
Can't make the right grip.
Yeah, what if they can't physically realize the state needed to generate, say, a 5 when the sequence demands a 5?
That's the prime directive.
Yeah.
And it is an absolute rule. Physical truth is committed first. Speech audits what was committed.
So reality comes first.
Always. The mapping is fixed. If your grip produces a knitability of, say, 2, but the Fibonacci state requires a 5, the system enforces no tick.
Silence. So this whole unbelievably complex architecture, it binds physical geometry and this esoteric deity language to an inflexible mathematical clock.
It does. The entire 24-tick cycle is predictable. It's deterministic.
Oh.
But it is utterly dependent on a perfect physical grip at every single step.
The choice for the machine isn't what to say.
Never. The choice is only whether the current physical truth is permitted to speak at all.
And that, it raises a really fascinating final thought.
Yeah.
In a completely closed, deterministic system like this, one that demands perfect adherence to a schedule, is silence the ultimate expression of control?